I'm going to start discussing the simplest organic compounds you can have, which are alkanes. They're made only of carbon and hydrogen, and you only have carbon-carbon single bonds. Sometimes you will hear them referred as aliphatic. You've got an aliphatic compound, and that means it's because you only have carbon-carbon single bonds. And they're called also saturated compounds. You might have heard the word saturated fats. That means they don't have any double bond or triple bond. So only carbons and hydrogens, and only carbon-carbon single bonds. They can be all in a chain, or they can be making cycles. And the simplest one you can have is only with one carbon, and it's called methane. Meth, because that's what the prefix we use to call something that has one carbon atom. Ane, because it's an alkane. The second one is called ethane, and it has two carbon atoms. And again, eth is because that's the prefix we use for a compound that has two carbon atoms, and ane because it's an alkane. The one with three carbon atoms is called propane, and the one with four carbon atoms are called butane. After that, with 5 carbon atoms, 6 carbon atoms, etc., you use prefix, Latin prefix. So pentane, 5 carbon atoms, hexane, 6 carbon atoms, heptane, 7 carbon atoms. I have a slide later on that gives you all the names, and so on and so forth. So all this is well and good. If you only have carbons, one carbon after the other, making a chain. You can even have them as a cycle. Like, for example, you can have 5 carbon atoms. So instead of being pentane, this compound would be cyclopentane. If you have 6 carbon atoms, cyclohexane. If you have 4 carbon atoms, cyclobutane. So that's fair enough. But what happens when you have branches? And that's very common in organic compounds. They are not all the carbons one after the other in a line or in a zigzag line. You have branches coming up and down your structure. How do you name that? Well, that's where the rules come from. So I don't expect you to be expert in the rules, but I'm expecting you to be able to interpret a name and have an idea of what the name is telling you without being afraid of what it means. The first thing I need to know is I need to count how many carbons I've got in my molecule, the one that I'm trying to name here. But not just count them. I need to track what is the longest continuous chain of carbon atoms. So if I think about this compound, let's say I start here. So 1, 2, and then I have 2 options. I can go up, 3. But then I'm stuck. If I want to go to the next one, I will have to jump and put my pen here and continue. So no, I don't want to do that. So that's not a good one. Let's try another one. Pointer options, pen. So again, I start here, 1 carbon atom, 2 carbon atoms, and instead of going up, I'm going to go down, 3 carbon atoms, 4 carbon atoms, 5, 6, 7. So, and if I want, okay, so I've got 7 carbon atoms that are in a line, and if I want to go to the other one, I cannot continue with the pen on the screen. I need to lift the pen and go and highlight my other carbon atom. So that's not a continuous carbon chain. The continuous carbon chain is the one that I've highlighted with zigzag, with a zigzag. And that is a continuous carbon chain that has 7 carbon atoms. And when I have, and it's an alkane because it only has carbon-carbon single bonds. So my compound is going to be an alkane that has 7 carbon atoms, and that's a something, a heptane. So my compound is going to be a heptane. And it's going to be a heptane, but with something attached. And that something I will need to name. Because it's not only heptane, it's not only 7 carbon atoms in a row. is 7 carbon atoms in a row with another carbon atom attached to somewhere in that chain. And the next thing I can do is say, where is it going to be attached? So is it at one of the end of the chain? In the middle of the chain? It could be in different places. So I tell my reader where my thing is going to be. This CH3 is in my heptane. And where is it going to be? Well, if I start number the carbon atoms, 1, 2, 3, 4, 5, 6, 7. I start from the right because the one closest to the substituent. Then I'm going to have something in my structure. So my structure is going to be a heptane, 7 carbon atoms, an alkane, with something attached to carbon 2. So what is that something? So what is that something that I mentioned before? Again, I've got my, what I call the main chain, and that's the one that has 7 carbon atoms, and it's going to be a heptane. And my heptane has in carbon 2 something. What is that something? Well, if that is what we call a substituent, and a substituent is formed by removing one hydrogen from something that is stable. So when I have the compound CH4, I have the compound methane. But when I have a fragment that has the carbon, 3 hydrogens, and a fourth bond that is free to attach to something else, then it's not a methane because it's not a complete compound. It's a fragment, it's a substituent, it's a methyl group. So methyl, when you, or ethyl, when you see the ending "-il", that means that is not a complete compound. This CH3 cannot exist on its own. How it can exist is attached to a larger molecule, as it is the case. So in this case, I've got this methyl group attached to my compound. And if you look at the name, 2-methylheptane. So methylheptane becomes one word, and the 2 tells you what the methyl group is. So when you look at an organic name, and that is worth remembering, never start reading from the beginning. Always go, in general, to the end of the name here, because that will tell you what it is. That will tell you, oh, it's an alkane, because it ends in "-ane. It's an alkane that has 7 carbon atoms, heptane. It's an alkane that has 7 carbon atoms and has a methyl group attached to it. And the methyl group happens to be in carbon 2. So it's always worth, when you read an organic name, if you want to know what molecule is talking about, your best option is to go to the end of the name and localize what's going to be the main compound, and all the other things that have in front will be substituents, different things attached to that main compound. I'm going to encourage you to stop the video and have a go at using the rules that I've given you to name this compound. This compound is more complicated, it has a longer chain, it has more substituents. When you have more than one substituents, you might need to use several numbers, or if they are both attached to the same you might need to use different numbers, and you will need to list them in alphabetical order. So if you have a methyl group, an ethyl group, a propyl group, you put them in alphabetical order. You use dashes to separate words and number, like I did with the 2-methylpentane. I put a dash between the 2 and the methylheptane, and commas when you need to separate numbers. Let's say that you have one methyl group in carbon 3 and one methyl group in carbon 5. You will write 3, 5, and you will write dimethyl, which means that you have 2 methyl groups. Just stop the video, have a go and see how you could name this compound, and let's see what answer you come up with. Stop the video now, please. Okay, I hope you stopped the video and had a go at naming this compound. It's a much more difficult compound. It's a longer chain. It has quite a few. It has 3 substituents. Hopefully you have spotted that the main chain is actually not along your right line of sight, but it goes slightly upwards, and it's 8 carbon atoms. So our compound is going to be an octane. Oct because it has 8 carbon atoms, ane because it's an alkane. So now, what does my octane has? Well, it has 3 different substituents. It has these 2 substituents, and these are methyl groups. So it's going to have 2 methyl groups, and so instead of saying 2 methyl groups, you talk about dimethyl. Okay? So my octane is going to have 2 methyl groups, and it's also going to have this substituent that has 2 carbon atoms, and a substituent with 2 carbon atoms is an ethyl group. So my octane is going to have 2 methyl groups, and I call them dimethyl. I use the Greek prefixes, and 1 ethyl group. So I put them in alphabetical order in front of octane. So if I put them in alphabetical order, the first one will be ethyl, and the second one, alphabetical order not in the prefix, but in the what it would be the main name of the substituent. So dimethyl would be second, and ethyl would be at the front. So I'm going to write here dimethyl. I'm going to leave a little space because I need to tell my reader where that methyl is, and I'm going to write here ethyl. Okay, so I've got almost the whole name. I'm telling my reader, this is an octane, so it's an alkane with 8 carbon atoms. My alkane with 8 carbon atoms has 2 methyl groups and 1 ethyl groups. And the last thing I need to do is I need to just number the carbons of the main chain to see to tell my reader where that ethyl group and those 2 methyl groups are. So you can only number them from one end or the other. So I could either do 1, 2, 3, 4, 5, 6, 7, and 8. And that if I do it like this, I would have my methyl groups are in carbons 3 and 6. So I put 3 and 6. And my ethyl group, or the ethyl group, would be in carbon 4. So an octane, so an alkane with 8 carbon atoms, 2 methyl groups, 1 in carbon 3, 1 in carbon 6, and 1 ethyl group in carbon 4. And just in case, because if I need to try to give the substituents the lowest possible number, I'm going to try numbering the molecule. 1, 2, from the other side, 3, 4, 5, 6, 7, and 8. And if I use the numbers at the bottom, then I still have a dimethyl, I still have the octane, I still have the ethyl group, because those haven't changed, but the numbers might have changed. So now, the methyl groups are, again, in carbons 3 and 6. But the ethyl group now has changed. Look. Now the ethyl group would be in carbon 5. So the methyl groups haven't changed, but the ethyl has. It has a higher number. So that would not be the best option. The best option would be to give to the compound the lowest possible number for all the substituents. So the numbers at the top would be the best ones. So 4 ethyl, 3,6 dimethyl octane. And that would be only one word. So again, if you look at a compound at the name of a compound, you start from the end of the name, not from the beginning, the end will tell you what compound you have. In this case, octane, an alkene with 8 carbon atoms. And all the other words will tell you what substituents you're going to have. Methyl, ethyl groups, the possibilities are endless, and where you're going to have them, and that's what the numbers are.